During your presentation, you said the autonomous driving promotes the use of plastics. And as a proof of that, you gave two examples of your front panel project. So I would like to ask an unprofessional question. What do the panels have to do with the mobility?
Yeah, so normally we know in the old days there was a grill to get the air into the vehicle to cool the engine. And with the concept of autonomous driving, that the concepts are based on radar systems, perhaps LiDAR systems, camera systems, etc. So high quality sensors which should detect the surrounding but should not be visible. You want to protect your sensors, your cameras, your radar, whatever, and therefore you have a cover. And due to some reasons on the engineering, they place those radomes, those radars, in the center of the vehicle, becoming a new design part. So you need a plastic component, which is on the one side fulfilling the aesthetic needs of being a design component of the vehicle and doing all the technical functions you need to protect and to support the sensors on the backside. So the one project here I've demonstrated with the BMW iX has a thermoplastic film inside where you have a heating circuit in to defrost the whole panel area in the winter time so that the sensors are working according to the needs. And you only can fulfill that with thermoplastic or with plastic materials because they are electromagnetic transparent. You can get light through, you get radar through, you get LiDAR through. If you would take a metal surface, then you would stop your electromagnetic wavelength at the metal structure. So this technology of autonomous driving vehicles will require more quality plastic components to protect the sensor and make that really autonomous driving.
Engel has a broad portfolio of technologies of injection molding, especially used for automotive industry. I mean lightweight material. Please describe in your opinion, the most important of them.
There are multiple technologies which are very important for the vehicles. Lightweighting, of course, is one. Working with thermoplastic-based composites to get the lightweight structure into existence is one. Then we have technologies to make transparent components, right plasticizing, injection compression molding, multicolor molding. These are all combined with film injection, back injection molding and PRO molding. This is a big topic for a lot of aesthetic and semi-transparent parts. Then of course we have a lot of focus points for LSR and elastomeric materials because there will be a huge amount of sealings needed for what kind of application. But you want to seal off connectors, you want to seal off plugs, you want to avoid any humidity getting into batteries or even the fuel cell. Or with all the hydrogen and water and oxygen, you want to seal off those areas. And so Elast and LSR are a big topic. Plastic-based composite technology, multicolor injection molding, injection compression molding, optical injection molding, foaming, as we had an example over here. This is important. In the long run, I think also concepts for more circularity will support the industry with more possibilities.
And the last question is the more general. Can we agree the lightweight materials are simply composites? Yes? And please tell me, what are the main challenges in injection molding of such materials?
So injection molding thermoplastic materials, they are a kind of insert molding technology. You insert something in the mold and you overmold it with injection molding process. So what kind of preciseness and what kind of temperature do we need on the thermoplastic component, independently if it would be a composite organosheet or it would be UT laminated and brought in as a skeleton. You need to be clear on the temperature. You need to prepare that the size, the right processing temperature agreed on, and that can make it sometimes more challenging to set up correct processing concept and window, especially when it comes to different thickness and different heat capacity in the material. The one material cools down faster, the other one is staying more in temperature. This will be then the process-oriented challenges. And of course, engineering those components, understanding where are the mechanical needs.
More than 600 participants, more than 20 keynote speakers. What's your opinion about this year's Engel Mobility Days?
So we are here at the end of the first day. We have more people showing up than we expected, so we are satisfied on that. Thank you very much also for the people coming from your country. So it's a great thing, and we hope that it's also interesting in the long run for the people, and thank you for the attendance.
Thank you very much.